Hello, everybody. Let's work on section 3 of chapter 4. It's hopefully a pretty quick one. Let event A equal the subject is telling the truth, and B, the event the polygraph test indicates that the subject is lying. Use your words to translate the statement B given A. What this thing says is probability of B given A. That's how you read that. So whatever comes first, whatever that probability is, given whatever that probability is. All right, so what do you have here? B is the probability, the polygraph test indicates the subject was lying. So the probability the subject was lying, given that the subject's telling the truth. Probably, and it's lying. No, that's a polygraph. The probability the polygraph indicates lying, given the subject's actually lying. That doesn't make sense. The probability that the polygraph indicates lying, no. The probability that the polygraph indicates truthfulness, no. Not truthfulness, was that it's lying first. The polygraph tests lying given the person telling the truth. Yeah, it's D. Number 2. Assuming boys and girls are equally likely, find the probability of a couple having a baby boy when their fourth child is born, given that the first 3 children were all boys. Well, it doesn't matter with the first. I mean, the first 4 didn't matter anything because we're looking at the probability of the fourth boy, the first child. It's either a boy or girl. So it's probably is 1/2, 1/2, or 0.5. However you want to interpret it. Subjects for the next presidential election poll are contacted using telephone numbers in which the last 4 digits are randomly selected with replacement. Find the probability that for one such number, the last 4 digits include at least 1 0. That's the clue right there, at least 1 0. Because the only thing we don't want is the one that has no zeros. So let's find that one. No zeros. Remember, the last 4 digits. So we have this number, that 9 out of 10 of those. This number here is 9 out of 10 of those. It could be 9 out of 10 of those. 9 out of 10. The reason it's 9 out of 10 because we don't have any zeros. So this is 10 times 100,000, 10,000. 9 times 9 is 81. 81, 81. Move it 4 decimal places. So that's the probability of no zeros. So 1 minus the probability of no zeros equals 1 minus 0.6561, which equals not 1.6560. So it should be 0, 4, 4, 3. Yes, which is 0.344. So I want 3 decimal places. Right? If in an experiment, college students were given 4 quarters or $1 bill, and they could keep the money or spend it on gum. The results are summarized below. Find the probability of randomly selecting a student who spent the money given the students were given 4 quarters. So if they were given 4 quarters and they spent the money. So 25 plus 18, it's 41. So their probability is 25 over 41. That's 8. That's 43. That equals 0.581. Yeah, because we're looking at specifically students who spent the money. We only want this one. And they purchased something. And they were given 4 quarters and they spent something. So that's the only thing I want right there out of these two. Probability of randomly selecting a student who spent money given they were given $1 bill. So I want only this. And they spent money. So here's I want 14 of those students. How many of them were given $1 bill? 14 plus 33 is 47. Two 3 decimal places. 0.298. What do the predicting proceedings result? What can we deduce from it? Student was more likely to be given, no, that's not what we're looking for. Students given $1 bill are more likely to spend the money than students given 4 quarters. No, that's not what it showed. A student given 4 quarters is more likely to spend the money than students given $1. Yeah. Yeah. So it's C. Table below results from experiments with polygraph instruments. Find the positive predictive value for the test. That is, find the probability that the subject lied given the test yielded a positive result. So positive results, we're looking at these. The subject lied. So I add both of those together, I get 58. So I got 45 out of 58. 776. So probability is 0.776. All right. Good luck, everybody.